Hi, good morning. In today's session, we're going to discuss about the numeric functions in Snowflake. These are the very basic functions available in the various databases like Redshift as well as Snowflake, BigQuery, all data warehouses. These functions will be available, but these are the functions we will be using regularly. Okay. But we won't use much arithmetic functions as well as exponent root function. These are all the mathematical functions. Okay. We won't use much, but rounding and truncation we'll mostly use in the SQL queries. In today's session, we're going to focus morely on the rounding and truncation part. These all um, functions are very, very important while you performing any kind of transformations. Now, first I want to say what is an arithmetic functions. Arithmetic functions have various subcategories. One is numeric functions have various subcategories. One is arithmetic, and then rounding and truncation another subcategory. Third one is exponent and root, third subcategory. The fourth subcategory is nothing but logarithmic. Fifth is nothing but trigonometric. And then these are the various subcategories under the numeric functions. Now, I'm not going to much focus on the logarithmic part, arithmetic part, exponent root part, as well as trigonometric part. These are the mathematical things. Is a like cos. It will give the cos theta value, sin theta value, okay, tan theta value to give all these values. These are all trigonometrical functions. But what I'm going to do is I'm going to focus which are the functions are used regularly in the Snowflake transformations. Okay. The first subcategory is nothing but the arithmetic function. It comes under the numeric. Now, if you see div0, okay. Now, this one other function, it will perform the division, like how we are performing division, right? The same thing, it will perform the division. Now, if the divisor, if you are trying to divide by some number, that number is 0, it's going to return as 0. But actually, in mathematical terms, they will say if the divisor is 0, we will say it's infinity. We'll say infinity, right? But what this div0 will do, right? If the divisor is 0, it will give the output as 0. Okay, it won't throw any kind of errors. That's what the div0 function is. Now, the div0 function, we have to provide two arguments. One is a dividend. Another one is divisor. Divisor means which value going to divide. Okay, that's a divisor. Now, it's very simple. I'm not going to focus much on the things. The dividend is 1. Divisor is 2. 1 divided by 2 is 0.5. And then dividend is 1. Divisor is 2. Same thing, you're getting 0.5. Okay, because the dividend is 1 and divisor is 2. 1 divided by 2 is 0.5. Now, if you see here, right, the dividend is 1. Divisor is 0. What value it will return? If you perform this thing, what value it will return? Dividend is 1. 0. Okay, it won't throw any error. See if you are see right? Division by 0 is error. Okay, actually it won't throw any error. It will return only 0. You can see here. Dividend is 1. This is 0. It's giving 0.00 something. It's giving. Okay, this is how you can perform the div0. Now, next one is div0 null function. If the divisor is null, it will return 0. Though the dividend can be anything, but divisor is null, it will return 0. If divisor is 0, again return 0 only. That's the use of div0 null function. Okay, now these are the basic things. Now, next one is rounding and truncation. It's another subcategory coming under the numeric functions. Now, these all functions are very, very important in transformations. Now, the first one you're going to see is rounding and truncation. Absolute value. ABS stands for absolute value. If you are giving any negative value, right, that will convert it into a positive value. That is called absolute value of numeric expressions. If you give any negative value, it will give you a positive value for you. Positive value for you. It's give you absolute. That's why it's saying absolute value of numeric expressions. Now, if you see here, right, I'm creating one virtual table using values. Okay, values is nothing but 0, 1, -2, 3.5, -4.5, null. Okay, I have like only one column 1, and then I'm using this column 1 in the absolute function, absolute value of column 1. Now 0.0 is going to be 0.0. 1.0 is going to be 1.0. -2.0 equal to -2.0 converted to
2.0.
2.0. See, all negative values convert into the positive values. Okay, this is nothing but an absolute function. It's an absolute function. Now they're creating one virtual table using values. They're creating so many values when null as well. If you are trying to give the values in the absolute value function, it will give convert all the positive sign values to negative values. Okay, this is what ABS stands for. I want to execute this one. It's very simple. The next one is seal. It's very, very important function. What the seal function will do, right? It will round to the nearest equal or to the largest integer. It will round to the nearest or larger integer. Okay, if I give 5.7, the value will be, because I'm saying it's rounding to the nearest equal or
6.
large integer, 6. If I give 5.7, the output will be going to be 6 for us. Okay, this is how the seal function will do. Seal function nothing but it will round to the nearest equal. Nearest means 5.7 means 6, right? It will go into the round to the nearest equal, or we can say the largest integer. And then now I'm giving some decimal value like 12.97. It will be coming to 13. That's what the saying here is. It will take to the nearest equal or largest value specific number of places after the decimal point. After the precision, after the decimal point, if you give any scale value, it will go to the nearest equal or larger values. The seal is come under the rounding function. Now, if you see the syntax, right? Seal function, you have to give the expressions, column name you have to provide, and then you have to provide a scale value. Okay, scale I'll say later. You have to provide a scale value as well. Scale value I will say later. Scale value is nothing but after decimal, how many values should come? That is called the scale expression. Okay, now straight away go to the example. For seal, what's value given? 138.135. It will take to 136. You might have a question. You might have a question. Though it is not greater than 0.5, why is it 136? But the seal function, what will do, right? It will take to the nearest equal or larger integer. Okay, if you give less value also, like for example, I'm saying it as 130.135. It will take the largest integer or near to the value 136. Now, here I given minus 978.975. Now, it's took to minus 975. You can have a question, why it's not went for 976? Because a negative value. Now you have to say minus 1 is a bigger value or 0 is bigger value. Minus 1 is a bigger value or 0 is a bigger value?
0 is bigger.
Same thing apply here. The minus 975.975, the seal function will take to the largest integer or nearby integer. Okay. Now, when compared to the minus 997.5, it's taking to the large integer in the sense it will come backwards minus 975. Now you have to say minus, now 975 is a higher value, huge value, minus 976 is a large value. 975 is a large value or 976
No.
large. I'm asking a question to you. 975 is a larger value or 976 is a larger value?
975.
75 is a larger
Minus
value.
975.
It's a larger value. That's why the ceil function will do. Ceil function will take to the largest integer or nearby or equal to the integer values. Okay, good. This is how ceil function will work. Now, what they're doing is they're creating on transient table. It's called test ceiling. They have two columns, float column, float type column, another integer column type. Okay, now we see we have the n value and scale value we have. Okay, and then I'm trying to insert the values in this test ceiling table. Now the values got inserted. If you look at here, using ceil function, you can provide the column expression you can pass, and then scale factor you can supply as an additional argument. Now, what is happening is minus 970.975. The scale value is minus 1. The scale value is minus 1. Let's see how it behaves. Just 1 second. Minus 1. Yeah. Now, if you see here, right, for ceil, we can provide the scale factor as well. Okay. For scale factor, they are given some conditions. The condition is if the scale value is negative, the return type is scale of 0. Okay. Now, what they are saying is, just if you look at here, right, if the scale value is 0, there won't be, after decimal, there won't be any digits will be there. You will get the exact value as minus 975. Minus 975. Now, the same thing, the scale factor, if you look at here, right, it's 0. Now, they are getting the values, 136. 136. Because though this column having the positive value, it will move towards a positive value called 136. It will go closely to the largest value. So ceil function go to the largest integer value. Okay, that's why you're getting 136, but the scale factor is 0. But if you look at same thing here, minus 970.975, the scale factor is 0. After decimal, it's not come anything. You should get minus 975 because though it has having the negative value, right? We have to go for a minus 975. And then if you have any null value in the scale factor, you will get the result as a null. You'll get the result as null. And then now let's look at the scale factor 1. Scale factor 1 means after decimal, you should get only how many digits? Only one digit should be scale factor. Now for that, we are getting 135.2. It's nearly going to the close value. For 135, what is the close value? For
0.2. 135.2.
See, I'm saying the scale factor is 1. We have to consider only one digit. Okay. The next huge value will be like only 2. 138.2.
Okay.
Okay, if you are making the scale factor 0, the entire thing is 0 over here. We'll get only 135. But what will happen, right? It's the next large integer will be a 136 for you. Though it's coming 135, right? The next value will be 136. And then if you look at here 0, you should not consider any scale factor after decimal. You should consider only minus 975 as well as though it's a negative value, I'm putting as it is. Okay, got it. This is how you can do the using ceil function. The ceil function, I'm again saying to you, you have to go to the nearest equal value or larger integer. Next one is floor function. It's one kind of rounding function to the nearest equal or smaller integer. This is the difference between ceil and floor. Ceil will go to the large integer or nearest equal. But what the floor will do? It will round to the nearest equal or
smaller integer.
Smaller integer. There's a difference between ceil and floor. If someone asks in the interview, I would say ceil will go for the larger integer or nearest equal. But the floor will do nearest equal or smaller integer. That's a difference. Now we can see syntax. You can provide the input expression column name and scale factor you can provide. And then what we can do is, instead of going for examples, now if you look at the 130.135, it will come to 135 because it has to go to the lower integer. Should go to the lower integer. If you're giving minus 970.975, what's the next lower integer value? Minus
976.
970 is the lower value. That's what this floor will do. But if you give ceil here, it will go to minus 975. Now, the same thing as the example is shown to us, the creating one table and then inserting the records with the help of some n value as well as a scale factor. Now, if you look at here, now just consider 0, 1. Scale factor is 0. Scale factor is 0. Though it is minus 975, it will go to the next lower integer called minus 976. And then if you take the scale factor as 0, and then though it go to the lowest integer is
135.
135. If you're getting any null value scale factor, you'll get the output as null. Okay, now this is how it will work. And then if you get in scale factor as 50, what happens, right? Though you have only 3 scale values, okay, after decimal we have only 3 digits. Now you'll get the same value. If you're having a more number of scale factor when compared to that after decimal places, you'll get the same values as it is. Okay, this is how you can do. And then if it scale factor is 1, you should consider only 1 decimal places. Though it's 130.1, you should put as it is 130.1 as it is. This is the difference between ceil and floor. Ceil will go for the largest integer, floor will go for the smallest integer. And then the next one is MOD. It's going to give the remainder of the input while you performing the division. If you have the dividend and divisor, it's this mod function, it's going to give the remainder for you. Now, though I have going to pass 2 columns, the first expression column is going to dividend, second expression column 2 is going to be a divisor for me. Now, what I'm going to do is, if you look at here, the dividend is 3, the divisor is 2. Here, dividend is 4.5, divisor is
1.2.
1.2. Okay, you have to give only the what do you have to give?
Remainder
you have to give. Okay, that remainder should be a fixed point decimal number, or you can say integer. Now, if you look at here, 3 divided by 2, the remainder will be 1. And then if you divide 4.5 dividend, the divisor is 1.2. If you divide right, you'll get like 3.6. And then next you can't able to divide. The difference will be, remainder will be
0.9.
0.9. This is how you can use a mod function. It's very important function while doing transformation. Next one is a round. Now, if you see here, right, the rounding function, okay, it falls under the ceil, floor, truncate, trunk. Okay, truncate, trunk, both are same. Now, what I want to do is, I want to pass input expression, I want to provide scale factor, I want to provide a rounding mode as well. 3 arguments I can supply. As of now, only one argument is mandatory. The remaining two are optional. Remaining two are optional. Now, I will say how the round function will work. It works on the both fashions. If you are getting 5.5, that value will be round to 6. If you are getting the value is 5.4, that value will be rounded to 5. If I am giving 5.4, it will round to 5. If the value is 5.6, it will round to. If the value is 5.6, it will round to
5.
I am saying the value is 5.6, it will round to. So the value is 5.6, the value will round to
6.
6. The value is 5.4, the value will round to
5.
5. Inside the round function, the two functions are available. What are two functions available?
Seal floor.
Seal floor. What a seal will do? It will
rounded to nearest integer or highest integer?
Largest integer value. Okay, the floor will go for the smallest integer value or equal or smaller integer value. But the round function will do both seal and floor. Okay, depends on the value. We're going to see one by one. Just to have examples. Now, if you look at here, I am passing 130.135. What's the value finally getting?
130.
135. Who getting 130? Where are you getting 136?
No, sir, no. 135.
You're getting only 135 because the round function will do the seal and flow. Now, if you look at the round minus 970.975, it is giving minus 976. Minus 976. Now, based on the two results, you have to say it works on the seal or which works on the floor. Just take this results. It works on the seal or floor. 130.
Seal, sir.
What a seal,
seal and floor, both round.
See, I am saying that 130/135 works on the seal fashion or floor fashion.
Seal fashion, sir.
Seal. Okay, minus 970.975. It's going to the minus 976. Seal or floor?
It's a floor fashion.
We can say it's a floor. Minus 976, it's a least value. Though it's a negative. Though it's a negative.
Negative.
Now you have to say minus 970 is a higher value and minus 96 is a higher value.
Minus 975 is higher, sir.
Higher value. Okay, then now you have to say what's the seal or flow?
Flow fashion.
Again, I am asking to you, minus 970 is higher value or minus 970 is higher value?
Minus 975.
75, right? Then how you are saying it's a floor? Floor will go for the least value, right? Correct. What you said is correct. Floor only go for the least value. Floor will go only for the least value, right? Okay, it's coming like a floor. Now talk about this one. 130/135 coming 135.
It's a seal fashion. Seal.
If it is 130, you can say it's a seal. 130 coming to 135. 130 or 130 coming to 135. The seal or floor?
Seal, sir.
If it is 136, you can say seal. It's the largest integer value, right? But it's coming on lesser value only, right? 130/135. It's coming 135. What's the seal or floor?
Floor, sir.
Previously, what you said to me?
Seals, I'm wrong, sir. So seal, floor only correct.
The floor is the right one. Now, see, they're giving us with the help of scale values, okay? Same thing you can do for the remaining stuffs. The round of 2.50. Okay, they are rounding to 3. And then 2.5 scale factor 0, and then half to even. Okay, just we are making it the 2 because they are given half to even. Okay, it should be even numbers. That's why I'm making it 2. This is how you can use a round function. A round function works both the ways. It works like a seal and flow. Now, if you give minus 2.5, right, it will come to the minus 3. And then if you give 2.5, though it's half to even, you're getting minus 2. Okay, everything is good. Now, the next one is we're going for sine function. It's very, very simple. The sine function, it's going to return the sine of its argument. Now, I passing 5. Though it's a positive value, it's going to give 1. Though it's minus 1 point, right? Negative value, it will give minus 1. Okay. And then for 0 value, it gives 0. It's very simple. If you give any positive value, it's going to give plus 1. If you pass any negative value, it's going to give minus 1. If you pass any 0 value here, it's going to give
0.
0. Okay, like you can pass any value, positive value is going to give 1. If you pass a negative value, it will give minus 1. If you pass any 0 values, it will give going to 0. Now, based on the rule, it's going to give, it will for easily for do some any kind of transformations. If positive value convert into plus 1, negative convert to minus 1, and 0 value convert to zeros. The next one is truncate function. Previously I've seen all the rounding functions, right? Now this is a one function. It's very, very important while performing the date and timestamp. Okay, and for truncating the integer values or decimal values, you can use truncate. For mostly for decimal values, for date and time, you use truncate function. This truncate function, what will do, right? It will take to the nearest integer close to 0. Or we can say nearest integer or smaller value with specified number of places after decimal point. The same thing will truncate will do. It will take it to the closest value to 0 or to the nearest value or smallest value with the specified number of places after decimal point. Okay. Now we're going to show the truncate function. It's similar like truncate and trunk are both the same. We have to pass input expressions and scale factor we have to pass. Now what we're going to do is I'm going to show now. Just once again, yeah. Now you can see I have one column minus 970.975. It's giving, I'm truncating means I'm removing all the decimal places. I'm removing all the decimal places and giving the values minus 975. That's called truncate. 130.135, I'm truncating all the decimal places and giving 135. Got it? This is how the truncate works. It will take to the nearest value or closest value or to be a smaller value. That is under truncate, will remove all the values after the decimal. Got it? If you apply truncate, right, it's going to remove all the decimal places. Going to remove all scale factors.
Only whole numbers will come.
Only the minus answer will come, and then going to remove all the scale factors. It will going to be 135. Now the truncate function we're going to use. Can use trunc function as well with help of scale factor. Okay, same thing I applied, right? If you are giving 0, it's going to remove all the decimals. It's going to give minus 975. And then if you are giving scale factor as 2, it will going to only consider 2 scale values going to consider after decimal places. It's going to give minus 970.97. And if you're getting a null value, it's going to give null. And then if it is 50, right, though you have only 3 scale values, it's going to give exactly as it is. This is how the trunc function will work. These are the very, very important rounding and truncating functions, mostly in transformation, right? You'll use floor, seal, round, truncate. All these things very, very useful while doing the transformations. Now, I'm not going to focus much on the exponential root as well logarithmic and trigonometries. Okay, if you are working in data science projects or any kind of R&D projects, then you can use all those exponent mathematical functions, logarithmic functions, trigonometric functions, all sin theta, cos theta, everything you can work on. Okay. Now I'm going to close session right now.